This section contains 3 questions, and the answers to these questions are in the form of double-digit integers. So let's start with question number 38. In the reaction sequence, so we have phenol reacting with CHCl3 in presence of NaOH. Students, this is the Reamer-Tiemann reaction, and the Reamer-Tiemann reaction in presence of chloroform will lead to the formation of salicylaldehyde. So we have PHOH and CHO at the ortho position. So this is our product P. Now this P is allowed to react with OH minus. The OH minus will just extract the acidic hydrogen of phenol, leading to the formation of phenoxide ion. And this phenoxide ion will now make an SN2 attack on the PHCH2Br and make the Br leave. So we are going to have the formation of PHCHO and OCH2PH. So this is the end product Q which is formed in the reaction. So the examiner seems to be interested in the number of carbon atoms which are present in the product Q. So if I talk about the number of carbon atoms, there are 6 carbon atoms in the benzene ring. There are 6 other carbons in the other benzene ring which is present. So we have a total of 12 carbons from the benzene ring, and then we have 2 different carbon atoms. One is the benzylic carbon and the other is the aldehydic carbon. So we have a total of 14 different carbon atoms in this case, and the answer to this question is 1,4. Let us look at the next question now. Question number 39. Consider the following reaction sequence. So we have been given cyclohexanone. Cyclohexanone is first allowed to react with NaOET. So this NaOET will first extract the acidic hydrogen, leading to the formation of a carbon ion, and then this carbon ion will attack the ester which is given to us, HCOOET. The carbon ion will attack the ester and make the OAT leave. So we are going to have the formation of the structure. Now this is our product A. Now A is first allowed to react with ethylene glycol in presence of dry HCl. So ethylene glycol in presence of dry HCl is used for protection of carbonyl carbons, and given the option to attack a ketone or an aldehyde, it will prefer to attack a aldehyde. So there will be a formation of acetyl at the aldehydic carbon, and in the next step it is allowed to react with LiLH4 followed by hydrolysis. So the LiLH4 cannot attack the acetyl now, it will only attack the ketone and convert it into an alcohol. So we have the structure, and when it is further subjected to hydrolysis, we are going to regenerate the aldehyde which is present. So we have a beta hydroxyaldehyde. This is our product B. Now it is given to us that this compound B is heated. So we have a beta hydroxyaldehyde which is heated. So beta hydroxyaldehyde undergo the loss of a water molecule upon heating to give us alpha beta unsaturated aldehyde. So this is the product R which is formed at the end of the reaction sequence. So the examiner is again interested in the number of carbon atoms present. So we can clearly see that there are 7 number of carbon atoms present in the product R. So the correct answer to this question is 07. Let us look at the last question in this paper, question number 40. In a given reaction, so we have been given 2 reactions in which Friedel-Crafts alkylation is taking place. So if we talk about reaction 1 now, we have this substrate reacting with anhydrous AlCl3. The anhydrous AlCl3 will extract this chlorine, leading to the formation of a carbocation at this position. The carbocation will now attack the benzene ring at the ortho position and will lead to the formation of a 6-membered side ring. So this is our major product X. Let's talk about the second reaction now. In the second reaction, we have 2 different chlorine atoms present in the reagent. So the Friedel-Crafts alkylation will take place 2 times in this case. So in the first case, we'll have the formation of this. And when the Friedel-Crafts alkylation is carried out again, the Cl will be extracted and the carbocation thus generated will attach to the ring at this position. So we are going to have the formation of this structure. So this is our product Y which is formed. The examiner is interested in knowing about the sum of number of carbon atoms which are only the part of the ring in product X and Y. Students, if we talk about the number of carbon atoms which are present inside the ring, that is, which are only the part of the ring. So we have 10 carbons in the first structure. All 10 of them are present as a part of a ring. And if we talk about the structure Y, we have 12 carbon atoms, and out of those 12 carbon atoms, 10 are again part of the ring. So the correct answer to this question is 10 plus 10, which equals 20. So students, we have to mark 20 as the correct answer to question number 40. This is it for today, guys. I hope the solutions were clear to you. Thank you.